You hear the word blockchain thrown around all the time, right? But what is it really? Well, if you look past all the hype and the crazy headlines, it's a piece of technology that's quietly trying to rebuild the very foundation of how we trust each other online. So let's break down what that actually means. To really get what blockchain is all about, you have to start with this one question. Think about it. Right now, every single time you trust someone online, whether you're buying a coffee or sending money to a friend, you're not actually trusting them directly. You're trusting a middleman, like a bank or a credit card company. But what if you didn't need them? What if that trust was just built right into the system itself? The mysterious creator of Bitcoin, Satoshi Nakamoto, said it best. This quote really gets to the heart of the problem. Our traditional systems force us to place an enormous amount of trust in these central authorities. And, well, history's shown us over and over that trust can be broken. This is the exact challenge blockchain was designed to solve.
So if the big problem is trust, blockchain is offering a pretty radical solution. It's often called a digital trust machine. Let's peel back the layers and see what makes it tick.
Okay, at its core, a blockchain is just an open, distributed ledger. Let's break that down because it sounds complicated, but it's not. Just think of it like a shared digital notebook. Distributed simply means everyone on the network has their own identical copy. And open means that when a new transaction happens, it gets added to everyone's notebook at the same time. This simple idea is what makes the whole system transparent, verifiable, and, as we're about to see, incredibly secure. So we have this shared notebook idea, but how does it actually get updated? How does a transaction get from your screen and onto this permanent shared record? Well, it all kicks off when someone requests a transaction. That request doesn't go to some central server in a basement somewhere. Instead, it gets bundled up into what's called a block and broadcast out to every single computer or node on the network. From there, all these nodes work together to validate it. Once they agree, that block is permanently locked onto the chain and the transaction is complete, visible to everyone. Let's zoom in on that validation step for a second. So here we see Alice wants to send some money to Bob. Her transaction is broadcast to these special nodes we call miners. Now, these miners are all in a race, competing to solve a really complex mathematical puzzle. This whole competition is called proof of work, and whoever wins gets the right to add the new block to the chain, which confirms Bob gets his money. And here is the secret sauce. This is what makes it so secure. Each new block contains a unique digital fingerprint. It's called a hash of the block that came right before it. This creates the super secure interlocking chain that goes all the way back to the very first Genesis block. Now, if anyone tried to go back and change an old transaction, it would change that block's fingerprint, which would instantly break the entire chain. The whole network would see the fraud and reject it. And that's what makes the ledger immutable, basically unchangeable. So this public, unchangeable ledger is absolutely revolutionary. But, it's not the perfect tool for every single job. Let's see how the technology has had to adapt. Yeah, the original design, the one Bitcoin uses, it has its downsides. All of that competitive puzzle solving and proof of work, it uses a massive amount of energy. And because the network is so huge and public, transaction speeds can be pretty slow. So for a business that needs things to be fast and private, that's just not going to work. To solve these problems, the core idea of blockchain was adapted into a few different models. On one side, you've got your public permissionless blockchains, like Bitcoin, where literally anyone can join. And on the other side, you have permissioned models, like private or consortium chains, where you have to be invited to participate. This creates a much more controlled environment. This table really breaks down the trade-offs. Public blockchains are maybe a bit slower, but they're incredibly secure because of that massive network consensus. Private and consortium blockchains, the kind businesses use, are way faster because there are only a few pre-approved participants involved. Essentially, you're trading a bit of that decentralization for more efficiency and privacy. Now, we've mentioned this idea of consensus and validation a few times, but how does a network full of strangers, people who don't necessarily trust each other, actually agree on what is true? This is the really mind-bending part. The answer is something called a consensus mechanism. The best way to think of it is as the network's rulebook. It's the agreed-upon process that lets thousands of distributed computers all arrive at a single source of truth, even if some of them are unreliable or, actively trying to cheat the system. A classic way to understand this whole thing is the Byzantine general problem. So imagine a group of generals surrounding a city. They all need to coordinate their attack at the exact same time to win, but they can only communicate through messengers. And here's the catch. Some of the generals might be traitors who send fake messages. So how can the loyal generals possibly agree on a plan and win the battle? That is the exact same problem a blockchain faces every second of every day. How can all the nodes on the network agree on the true state of the ledger when some of them might be trying to cheat? The consensus algorithm is the battle plan that allows all those loyal generals to coordinate and win. And there are different kinds of battle plans. We've already talked about proof of work, which relies on raw computing power to stay secure. But there's a newer, much more energy-efficient method called proof of stake. With this one, instead of burning energy, participants lock up, or stake, their own cryptocurrency as collateral to get a chance to validate transactions. And the difference here is fundamental. With proof of work, security comes from computational power. It's all about who has the most powerful computers. With proof of stake, security comes from economic investment. Who has the most currency staked in the network? So to attack a proof of stake system, you'd have to own more than half of all the currency on the entire network, which would be astronomically expensive and would probably crash the value of the very thing you were trying to steal. So we have this secure, trustless ledger technology that comes in a few different flavors, but its potential, it goes so much further than just creating digital currencies. If Bitcoin was the proof of concept that showed us blockchain could be digital money, the next huge leap forward was Ethereum. See, Ethereum's creators realized you could store more than just transaction data on the blockchain. You could actually store and run computer code. This transformed the blockchain from a simple ledger into a decentralized world computer. The key to this whole new world is the smart contract. It's really just a piece of code that lives on the blockchain. And just like a vending machine, it automatically does its job, whether that's releasing funds, registering a property title, or casting a vote once certain pre-programmed conditions are met. No lawyers, no middlemen, just code. And the benefits are really powerful. Because these smart contracts run on the blockchain, they're completely autonomous and tamper-proof. They get rid of the need for intermediaries, which means huge potential savings in both cost and time. And they allow for trustless execution of agreements between people who don't even know each other. And when you put all of these pieces together, you get this explosion of new applications. We're seeing it in decentralized finance, or DeFi, which is trying to rebuild the entire financial system without banks. We see it in NFTs, creating verifiable digital ownership for art and collectibles. It's being used to create transparent supply chains, secure personal healthcare records, and even to experiment with new kinds of voting systems. So what started as a clever solution for digital money has turned into something so much bigger. It's a new foundation for a more decentralized internet. It's a platform for building systems that are more open, more transparent, and more controlled by their users. The foundation has been laid. The truly exciting part is finding out what we're all going to build on top of it.